In the canyon, you look at the canyon, and you see a very sharp V-shaped canyon, very rugged walls. Something happened there very, very quickly to form that canyon. And the yellow comes from the hydrothermal water, that superheated water that's percolating through, and there's a lot of what we call hydrothermal metamorphism. It's one thing that evolutionary scientists and creation scientists agree on to some respects. They believe, of course, this was formed during the Ice Age, which they believe is tens of thousands of years ago or more, sometimes up to 1 million or more. We believe, of course, this happened after the flood, so that these Ice Age would have happened maybe 4,000 years ago, something like that. The question is, if they believe in all these multiple Ice Ages, why is there just one canyon that looks like it formed very recently? And it's still very rugged. It looks like it just happened.
Hello, everyone. Welcome to the Creation Podcast, the show where we discuss the science that confirms Scripture. I'm your host, Trey. America is home to stunning forests, mountains, monuments, and other wondrous features. The unique beauty of many of these locations have prompted both state and federal governments to designate these locations as national or state parks. Thousands upon thousands of travelers visit these sites daily to experience their awe-inspiring grandeur. But where did they come from? Many scientists claim that they formed slowly through uniformitarian processes. But is that true? Join us as we journey through the parks across America. In this first episode, we're going to take a look at some of the features of America's oldest national park, Yellowstone. And I have with me today Dr. Timothy Clarey, ICR's resident geologist. Thank you for being here, Dr. Clarey.
Oh, it's great to be here. It always is.
Awesome. And I want to apologize for my voice a little bit. As you know, it is the worst allergy season in Texas right now, but we're here.
I understand.
We're going to do this. All right. So we're talking about Yellowstone. Let's give just a little bit of history before we dive into the science. So geologist Ferdinand Hayden led an expedition through what would become Yellowstone in 1871, and it was his report that convinced Congress to set aside the land for the purpose of making a national park. Do you have any other insights or thoughts into that whole story?
Well, Hayden was one of the first geologists to actually go and do a lot of mapping in the American West, and so it is rather surprising, though, that 1 year after he did this study that they made it a national park. It was, I think it's the very first national park in the world. I'm not certain of that, but I heard that at one time. But it was, quite a while ago. And then there's, of course, since then we've had lots of national parks and then even national monuments and the national forest and all these things. And what's amazing is the very first national parks, mostly in Wyoming, it spills over into Idaho and Montana a bit. Yellowstone does. But they also have the very first national monument there, which is Devil's Tower in Wyoming, and the very first national forest, which I believe is Shoshone National Forest up there near Yellowstone. So one of my favorite states is Wyoming, where I went to school for one of my degrees, and it's all the beauty there. It's fitting that they would have the first national park, first national monument, and the first national forest.
Yeah. My wife and I went a few years ago, and however much time you think you have to go and visit everything, plan more time, because there's just so much to see, and it's so beautiful. And if you can go when it's not crowded, hey, make an effort, because 3 million visitors tour Yellowstone each year, which is a lot of people.
It is, and it's basically a figure-8 road that goes through it, a 2-lane road, and I've been through it about at least 20 times, different parts of it. And every time you go, there's always something else. And most of it you don't see because they're not on those roads that make that kind of figure-8 shape. Most people see the big highlights. They'll see Old Faithful, they'll see the Mammoth Hot Springs, they'll see the canyon, and then they zip on through. But there's a lot to see, a lot of other things you can do. I learned the more you go, the more things you can do that are you maybe never did before.
Well, let's talk about how Yellowstone got its start then. So I remember growing up, I think in elementary school was the first time that I learned that Yellowstone was a supervolcano. And there was a lot of talk about, if it goes up in a big eruption, half of America is going to be wiped out and all that jazz, which that hasn't happened. I remember in elementary school, I was afraid it was going to happen within the next couple of months. But Can you tell us what a supervolcano is?
Well, a supervolcano is actually a pretty new term. When I went to school, it didn't exist. I mean, but they found out that some of these volcanoes, like Yellowstone, there's like 10 or 12 of them, I believe, in the world, erupted so, large in such a magnitude that they spread ash and, debris for, like as you mentioned, over half the United States, massive amounts of area covered by the explosions. So they deem these not just volcanoes, but supervolcanoes. But really, I don't believe there's any particular number to it other than this one's really, really big, so we're going to call it a supervolcano. Okay. And so, people scare you about Yellowstone erupting, because some of the ash came all the way to Texas. And so it did cover half the country, but I don't think it would, even if it were to erupt, I don't think it would kill people over half the country. That's kind of an exaggeration.
But it could erupt?
Well, it could, but I doubt if it'll erupt like it did, because in our interpretation here at ICR, this was a flood event. Yellowstone supervolcanic eruptions happened during the flood, when the floodwaters were receding. So this would have been 4,500 years ago approximately that these eruptions occurred. Now, the conventional geologists, of course, believe much older dates. We can talk more about that.
Right.
But I think this is something that happened during the flood, just like the waters covering the earth happened during the flood year, and have never happened again. I don't believe these supervolcanoes are going to erupt as a supervolcanic eruption. We haven't seen any of that type of eruption in historic times, so I believe most of these, including Yellowstone, are flood events. That if there is a little eruption today, it'll just be a little poof by comparison.
That makes sense. Okay, so the central plateau of Yellowstone has 3 overlapping calderas. Okay, so what's a caldera and why is this important?
Well, calderas are kind of collapsed volcanoes. So volcanoes build up, these volcanoes that have very explosive magmas, like Yellowstone, that has a lot of quartz in it, a lot of silica, we call it. Those normally form over, I don't want to maybe go down this path, but over subduction zones where you can kind of distill the melts and get the right type of chemistry without getting into the details. And Yellowstone, because the eruptions came through the continental crust, picked up a lot of silica. The continental crust has a lot of quartz in it, so it became a very explosive type of eruption. But each time it erupted, it would collapse. So much debris was sent out that it would collapse upon itself. And normally that would be the end of a volcano. A lot of volcanoes, like Crater Lake National Monument, was a volcano that erupted and kind of collapsed on itself and formed a caldera. So calderas are often the last thing that happens is the volcano will erupt so much that there's a void and everything just kind of falls down. It makes a big circle, but it's much more subdued than the volcano would have been with more of its peaked cone.
And so I have in my notes here that of the 3 calderas, it's kind of agreed upon that the largest eruption occurred first, because of the sizes of the calderas, it got weaker over time. Can you speak to that a little bit?
Well, that kind of fits with our model that, during the flood, you had these eruptions going on. You had lots of turmoil inside the earth in the mantle. Plates were moving very, very quickly. Subduction was happening very quickly, whereas today it's all these processes have slowed way down to, just a little bit, a couple centimeters per year, a couple inches per year. And so you don't have the internal turmoil, for lack of a better word, to really cause these supervolcanoes that we have going on today. So by making it less and less, that kind of fits with the lessening of the effects of the flood as we progress towards the present.
Right. Okay.
Hopefully that makes some sense.
Yeah, that makes sense. And so there's also geologists have noticed that there's a line of calderas that extends from Yellowstone all the way to Oregon. I'm imagining, you explained what a caldera is. What this communicates to me is that there's just a line of volcanoes going off like black cats or something, But what do conventional scientists believe about this line of calderas that leads to Yellowstone?
Well, most conventional scientists would say this is a hot spot. So there was some sort of a mantle hot spot below the crust. So as the plates were moving over the crust, it would leave a trail, almost like breadcrumbs leaving a trail to mark where you went. It would burn a hole through the crust. And they also use that same explanation for the islands of Hawaii and the subsea volcanoes that extend for miles and miles and miles across the Pacific. Same idea that you had rapid, the plates were moving across this and you kept making volcanoes, burning a hole through it. Essentially, as you kind of go across, you have a candle burning and you're moving across. You continually keep burning and exploding as you move along. So they do see sort of a timing of these are youngest at Yellowstone. They get older as you go towards Oregon. And so for whatever the cause is, which nobody's really sure, why would you get a hot spot to develop, for example, it does seem to be a pattern there. Mm-hmm. Now, as flood geologists, we think this all happened during the flood year. Islands of Hawaii happened in the flood year. All the subsea or the seamounts, associated with Hawaii happened in the flood year as well, because we believe the plates were moving fast. Everything was kind of moving fast. Volcanoes are erupting more quickly in greater numbers, especially towards the end of the flood, like we see at Yellowstone. And then eventually the last couple of eruptions happen right where Yellowstone National Park is, and these calderas kind of coalesced and collapsed on top of each other. Mm. And so the final eruption, evolutionary scientists would say about 600,000 years ago, I believe. But of course, we believe that was only like 4,500 years ago when the flood occurred. So we would we would kind of follow that same pattern, that there is a pattern, a relative pattern of getting younger towards Yellowstone or older towards Oregon. There was something down in the mantle that was kind of burning a hole, but we think it happened much more quickly than what conventional geologists would say.
Right. It's interesting to me that this is just another really clear aspect of looking at kind of the same evidence, kind of the same data, looking at the same thing and interpreting it in such a different way. But I can also imagine, okay, I know that while this was happening, there probably weren't any people watching this go off, right?
No, the only people on the earth at that time, if we're correct in our interpretation, this is part of the receding phase, would have been, Noah and his family on the ark.
On the other side
halfway around the world, yeah. And so there were a lot of volcanoes going off, and this was one of them. And there's some places around Yellowstone, 10,000 feet of volcanic debris that built up. This eruption was tremendous. These series of eruptions, and so there's lots and lots of debris still there today that we can see the thicknesses of, and the debris flows and the volcanic evidence was just tremendous. It would have been hard for anybody to be alive then, but that's another reason why I believe this happened during the flood. You couldn't have animals roaming around there. We don't see fossils of any animals really mixed in these volcanic layers either.
Right.
And many of them might have actually erupted underwater. So the water was still maybe not off the continents. Maybe it was just starting to come through at that point, but some of the area was probably still covered by water as the water was starting to recede.
Gotcha. That makes a lot of sense. Imagine how terrifying it would be to actually see that. Clearly, the catastrophic conditions slowed, and now we have the processes. We have what we kind of see today. There's little plate motion, very little volcanism. There's some, here and there, but it's definitely slowed down. But Yellowstone is unique in a lot of ways because of what was in its magma, if I understand that correctly. Can you explain that a little bit?
Well, that goes back to the idea of the silica or the quartz that's very high content in the magma. The chemistry is different than, say, Hawaii. Hawaii produces a black lava it's basically called basalt. Like the ocean floor is basically made out of basalt, very black rock that's lower in quartz. So when it erupts, it flows more water-like, very, very thin and fast. And it doesn't build up big, sharp mounds. It builds up shield volcanoes. Whereas Yellowstone and most subduction zone volcanoes are a different chemistry altogether because of the processes that formed them. In this case, Yellowstone's in the middle of a thick continental crust, so it picks up a lot of the silica from the crust. And the magma then becomes very explosive. So it makes a different type of magma that explodes, like Mount St. Helens or Mount Pinatubo, where most of the subduction volcanoes are around the Pacific, the so-called Ring of Fire. And those are a different type of magma altogether, and that's why you get explosive magmas versus the less explosive ones like at Hawaii.
So silica is what's causing
silica is the key.
Okay.
And you need the silica actually to make the geysers too. So Yellowstone, there's still magma close to the surface. They can kind of image that with some geophysical techniques. You can kind of see where the magma is, and it's not very deep. So there's still liquid molten material down there that's fairly shallow, and that's what superheats the groundwater that comes in contact with it or gets close to it. And with the silica, you can actually have the right kind of, the silica creates the conditions where you can get these really thin water, almost like pipes. that maintain themselves for a long time. And you can get those conditions, the silica-rich magmas, the silica-rich rocks above it, and the magma close to the surface superheats the groundwater, gives us the conditions for geysers. So Yellowstone has over half the world's geysers.
Okay.
Within
Before
its
we go
park
any
boundaries.
further, what's a geyser? I mean, I know what it is.
Well,
What's
there's
a
different
geyser?
types of geysers, I guess, in some ways, but traditionally you think of Old Faithful.
Yeah.
Where the water will shoot out, superheated groundwater will reach a point where it finally finds its little conduit. Again, the conduit's formed because of the silica.
Okay.
Silica, fuses together kind of the rocks and makes these little pipelines.
Makes the plumbing.
It makes the plumbing. That's what I was trying to think of. And because of that, of course, that can constrict the water till it gets to a certain point where it finally sneaks out and the steam comes up, and immediately it flashes the steam, and you get this big geysering going off. And so there's lots of geysers. Old Faithful is special because it's so timed. The timing of it is so consistent. It's about every 90 minutes, I think, now. Years ago, before there was an earthquake that kind of jostled some of the piping, the plumbing in Yellowstone, it was even more regular than it is now. So there's always a little variation in it. But it generally goes off about every 90 minutes. And so some of the eruptions are bigger than others. It depends on the amount of groundwater from year to year, from month to month. Sometimes it can vary the size of it. But geysers are really superheated groundwater that is able to shoot to the surface. And there's other ones that just kind of dribble out. There's mud pots and mud pools. And it depends how much mud is in the area, or if it's a clean pipeline system, if there's a lot of mud that got mixed in with the plumbing is. It'll give you different types of hot springs or hot geysers or mud pots and pools. And so you can see all that at Yellowstone. It's really amazing. It's one of the few places in the world you can see all these by just driving around.
Yeah.
And it is fairly safe as long as you stay on the boundaries, stay on the boardwalks.
Right.
Although,
We'll throw some pictures of some of
well,
these
recently
things.
there was a problem with one of them that actually one of the boardwalks got kind of collapsed, and there was a little bit of a geyser eruption that went over one of them. They had to move it back. So there's you never know for sure.
Right.
But it's pretty safe if you stay on the boardwalks.
Generally speaking, yeah. Okay, so you mentioned geysers. We've mentioned several features briefly. What's the difference between a geyser and a hot spring? I mean, I know they both have to do with hot water.
Right. Well, hot springs, like the one at Mammoth Hot Springs, are really not associated with the magma.
Okay.
And so most hot springs, like if you go to Hot Springs, Arkansas, you go to Hot Springs, there's another Hot Springs in Thermopolis, Wyoming, there's hot springs all around the world. Many of these are just because there's hot groundwater coming up through fractures or faults, we call them in geology. And so you're bringing up water that's down deep in the earth that gets heated by the earth's internal heat, and it has a plumbing system to get to the surface. And so as it comes up to the surface, it'll precipitate some of the minerals that it collected. As it's in hotter temperatures, it can carry more minerals. It gets to the surface, precipitates those out, and builds up these little piles of terraces almost of usually calcium carbonate or something on that line, which is what limestone's made out of. And we call that travertine or something on that. And so but those are different. They're not from the hot magma. They're not superheated groundwater. Like the geysers are. Those are just from hot groundwater.
Okay.
So it's a difference in the temperature, and it's a difference in the source. There's deep groundwater coming up along fractures, makes most of them are hot springs. And those can vary. Oftentimes they are 100 degrees Fahrenheit, whereas the water in Yellowstone, geysers, can be close to the boiling point, 150 degrees easily Fahrenheit. And so it's a much, much hotter waters.
Right.
So there's differences. Again, a lot of it's
Forbidden.
defined based
Don't
on
touch it.
Right. Most of it's defined by temperatures. There's warm springs, there's hot springs.
Right. Okay. And what about rainbow pools? I remember when my wife and I went, we could just stare at the rainbow pools. They're beautiful. What's going on there?
Well, that has to do with biology, which is it's not my expertise, but I know enough about it to be dangerous.
That's good.
Some of it depends on the temperature of the water, and certain thermophilic bacteria can actually live in really, really hot waters, which amazes people. These animals can live in such hot water, and some of them produce certain colors based on the wavelengths that they're using for their photosynthesis, things like that, and they produce sugars and foods based on certain temperature. Others use a different wavelength; they absorb different temperatures, and so they appear a different color as they kind of go off. If I understand that right. And so there's some of it really varies based on a little bit of the water temperature.
Right.
So you see these different colors around the pools. You see the yellows, you see the kind of oranges, And those particular colors are based on different bacteria. They're able to live in those particular temperatures, or as the water cools just a little bit, you get different bacteria.
Right.
And so you get these kind of rings around some of these geysers, which are really, really pretty.
Yeah. Yeah. We'll throw up some pictures of those too.
Okay.
I feel like this is going to be a very picture-filled episode. Sorry, Vicky.
Well, there's a lot to see. I mean, and unfortunately, if you don't go there, you see it, it's pretty, but when you go there, it's just unbelievable. I mean, you smell the groundwater. You smell a lot of methane.
Yeah.
Sulfuric acids and things like that. You smell almost like a rotten egg smell. Mm-hmm. And it's a pretty amazing place. I mean, it's these sights and the smells.
Yeah. Well, then you mentioned Mammoth Hot Springs. That was one of my favorite locations when I went. It's beautiful. It's weird. Like, I would describe it as almost alien is how it looks. So we'll throw a picture of that. I just want to know, how do geysers and rainbow pools and Mammoth Hot Springs, or hot springs in general, how does any of these weird, unique features, how do they fit into a biblical time frame? What's the purpose? Mm-hmm.
Well, I think that they all fit into the biblical time frame of the flood. And most of these conditions were, the volcanoes erupted during the flood. Most of the supervolcanic eruptions happened during the flood as the water was receding. And so since that time, these have kind of settled down, and the groundwater, the conditions of the rainfall, of course, changed quite a bit from the Ice Age till now. Mm-hmm. There's probably a lot less rain than there was immediately after the flood when the oceans were really hot. And so you kind of work into an equilibrium of where the water table is today and the temperatures there today. And you're able to get these hot water. You still have that magma down there. That magma still shows this stuff's pretty young. Mm-hmm. It's hard to imagine this stuff's supposed to be over half, million years old, and the magma's still that close and still that hot. And so having that hot magma, to me, as a geologist, tells me that this stuff's still fairly young. And if it's really 500,000 years old, as they say, the last eruption is supposed to be 600,000 years ago, why hasn't it erupted? Mm-hmm. Since there should have been more eruptions. But it seems to have really come to a screeching halt. After those last couple eruptions, everything kind of just calmed down. You reach this equilibrium with the hot water, still, forming superheated water with the magma. But the magma, to me, that tells you that this stuff's still pretty young.
And it seems as though it's actually, degrading is not the right word, but like, as an example of what I'm trying to say. So we would see signs that were like, this used to be a wonderful attraction, whatever this feature is, but the water and the heat isn't there anymore. So there's already features that, like, from the 80s and 90s and before that just stopped because it's cooling down. Right,
like you see that at Mammoth Hot Springs. You see some of the areas have gone, there's no water coming out. Mm-hmm. So all of a sudden, all the color is there that they would have had from the hot bacteria, even though it's not as hot as some of the geysers, the water around the geysers and the pools. It quickly looks just gray and just, kind of gets ugly. Mm-hmm. And the prettier parts are where the water is percolating out, still keeping the bacteria alive and keeping everything happening. But it's amazing how, God engineered all this to work and for animals to live in these high temperatures and to give us these colors. And I think a lot of it's because God just likes to showcase his beauty of his creation. Yeah. And Yellowstone, fortunately, we preserved this as a national park, so we haven't had a lot of, hotels built in there and billboard signs up all over. It's all monitored pretty well by the federal government. Something maybe too restrictive. Depends on your views. Right. But nonetheless, it's preserved this, and I think it's a great thing because this park is a very unique feature in the North American continent.
Yeah.
And even in the world, for that matter, because it does hold so many of the world's geysers.
Absolutely. Well, we just have one other major piece of Yellowstone to discuss. I mean, we could discuss Yellowstone for forever. Mm-hmm. If we talked about animals and plants and all sorts of stuff. But let's talk about what is called the Grand Canyon of the Yellowstone. So this is a 20-mile long, 1,200-foot deep canyon. And, well, the walls are yellow. Mm-hmm. Can you tell us how this and of course it's Yellowstone because the stone is yellow. But yes,
not everywhere, but but in the canyon, you look at the canyon and you see a very sharp V-shaped canyon, very rugged walls. Something happened there very, very quickly to form that canyon, and the yellow comes from the hydrothermal water, that superheated water that's percolating through, and there's a lot of what we call hydrothermal metamorphism. So a lot of the rocks that used to be volcanic have changed color because of this superheated groundwater kind of percolating through. And so that's, I believe, is the best explanation, the simplest explanation for why we see so many yellow rocks in Yellowstone. Most volcanic rocks would be gray or kind of a reddish color. And we still see that too in Yellowstone. But it's, the canyon itself is one thing that evolutionary scientists and creation scientists agree on to some respects. They believe, of course, this was formed during the Ice Age, which they believe is, tens of thousands of years ago or more, sometimes up to 1 million or more. We believe, of course, this happened after the flood, so that these Ice Age would have happened maybe 4,000 years ago or something like that. And both of us agree, though, that there was some sort of ice dam that dammed up one of the lakes in the middle of the caldera, like Yellowstone Lake. And then as the ice melted away and the Ice Age started to fade, the water was catastrophically burst from that lake and formed that 20-mile-long canyon very quickly. And so even the evolutionists agree on that. The question is, if they believe in all these multiple ice ages, why is there just one canyon that looks like it formed very recently and is still very rugged? It looks like it just happened. It's not all smoothed down like you'd see if this was 1 million years old. You'd expect the sides to be a little more smooth, but the material is washed away completely, just like we see at Grand Canyon. It's swept clean, except for the rugged walls. And so, but it is interesting that we both agree that there was some sort of catastrophic formation of the canyon. But our explanation is a little bit better because we only believe in one ice age, one ice dam burst. Their interpretation, being uniformitarianists, would expect to see multiple ice ages happening, and you wouldn't just get one simple canyon. I wouldn't think it's a little more complicated for them to explain why there's only there's one ice dam that seemed to form it. Why didn't it happen before?
Right. Well, semi-related, since it is called the Grand Canyon of the Yellowstone, would you say that the Grand Canyon and Grand Canyon of Yellowstone were formed in the same manner?
Well, similar, but I think different. I don't think there was an ice dam that burst or even a lake that burst to form Grand Canyon. I think it was just part of the receding phase. And so you had uplift going on. Grand Canyon lifted the ground up about 5,000 feet. At the same time, the water was receding. So they happened about the same time, but for different reasons in some ways. And that water was coming in all directions. So we see these, not just one directional flow, we see huge side canyons all the way along the length of the 277-mile Grand Canyon that shows there was water coming in all directions. It wasn't just one simple directional flow. So I think they formed at about the same time, but a little bit for different reasons. I mean, one happened after the flood during the Ice Age at Yellowstone. The other happened as the water was receding. But both of them swept the canyons clean. Yeah. They just tore the material and moved it on out, but for different reasons. One was the receding phase, one was the Ice Age after the flood was over.
Awesome. That makes a lot of sense. Well, the last little bit that I want to talk about is trees, actually. I know trees are not rocks. Sorry to
But they are. When they're petrified.
Because, yes, okay, so we are talking about fossilized trees, and they're all sorts of different variety. We have a sycamore, walnut, chestnut, oak, maple, redwood, magnolias, and some of these are even standing vertically. Mm-hmm. So these are fossilized trees standing vertically, contained in about 20 different layers. So from a conventional science point of view, like how could a tree be in two different layers that are millions of years apart, right? So how do conventional scientists explain this? How do flood creationists explain this?
No, it's a vastly different story here.
Yeah.
So conventional geology will teach you that you don't even have to go to the park. You can read the signs. They'll tell you that these formed over multiple eruptions over the course of, maybe over 2 million years. Because the calderas at Yellowstone are supposed to be, I think one's supposed to be 2.5 million years old, and then 1.8, if I remember right, and then like 0.6 or 600,000 years ago. So these eruptions, these multiple eruptions, and those are just the calderas that would have been multiple eruptions going off, at least 20. And each time in between, you had thousands of years of time, or hundreds of years of time, enough for trees to grow. And so each time they erupt, they bury another layer. So you see these 20 layers or more with different trees. Now, they're not all standing up.
Right.
Most of them are laying down, actually, when you find them. But there's quite a few that are standing up because their base is thicker and wider, and so their heavy side is down. But if you look at the trees, and I've gone up Specimen Ridge in Yellowstone, you can climb up there, look at them, you'll see that there's no roots. They're just cut off, as if these trees were ripped off right at their roots, left the roots behind, and just the stumps. So you have these wide, kind of a triangular-shaped trunk. Sometimes they're sticking up a little bit, and you see that. But what's makes it different in terms of the flood story is we believe these all happen in the flood year. So how do you have time for all these trees to be deposited at different levels? Well, if you go to Mount St. Helens, which erupted in 1980, Steve Austin, my predecessor in geology here at ICR, studied the trees that were floating around Spirit Lake after the eruption. They ripped off the sides of the hills and washed back on the lake. And a few years later, he went out there and he noticed that some of the trees were actually sinking. They were becoming waterlogged and they were sinking. And they were sinking vertically into the sediment at the bottom. And they're always sinking the heavy side down because that's the heaviest side of it. You get a big long tube and one side's thicker, it's going to be heavier, it's going to sink that way. So some of the trees are still floating around over 40 years later, but others have sank to the bottom at different levels as they become waterlogged. So we think that all these 20 levels of trees can be explained by, one or two eruptions that happen very close apart. You don't have to have thousands of years in between each eruption to get each tree layer, as the evolutionists would suggest. And even they've backed off a little bit on some of their arguments because they also see the logic behind that. And so some of the evolutionary scientists have kind of backed off pushing the story of the 20 different levels could be explained by some of these sinking to the bottom. But what really, to me, is the strongest evidence for it is none of the trees are grown in place because none of them have roots. So to me, they all look like transported in. So the best explanation is that these trees were all transported in during the flood as these eruptions were happening at Yellowstone. And you still had water around, and they were just sinking at the bottom at different levels. And so it's just a coincidence that they're standing up because the heavier sides sank down. The flood gives us the best explanation for what we see.
Yeah.
It really does. I mean, it makes sense of what the different levels, because you had different trees sinking along in the water at different times, more sediments coming in, more trees sinking, more sediments coming in, more trees sinking. All of this can be done in one eruption, or maybe just a couple of short eruptions. And so to me, the flood offers the best explanation for what we see, like at Specimen Ridge and all these trees in Yellowstone, petrified trees. And then, of course, the high silica, high quartz groundwater percolating through those rocks, of course, petrified the trees to what we see today. So it's amazing. And we see this in other places, in other national parks as well. We see the same process up at Theodore Roosevelt National Park in North Dakota. We see tree stumps again. And some of them vertical with the heavy side down, some of them laying down, some of them tilted on angles, and all of them have no roots. Even the evolutionary articles talk about, we know these trees grew in place, but none of them have any roots. So they kind of contradict themselves. And this is the same thing we see at Yellowstone. So to me, the flood explains the ones in North Dakota at Teddy Roosevelt National Park and explains the ones in Yellowstone better than any conventional explanation.
Awesome. Well, I really want to thank you for all of the knowledge that you've brought to this topic. Yellowstone is beautiful, and I feel like a lot of people just go, and if they don't have the proper grounding, the proper knowledge, they'll believe all the information that's on the signs because it's so very well presented, and it's pretty convincing.
Right. It sounds like, this is science.
Yeah.
And so you got to believe the millions of years that these things happen over millions of years. But that's not the truth.
Yeah. And I mean, and all the park rangers, they'll engage in a conversation with you, super friendly, but all of their worldviews are from that old earth uniformitarian view.
Whether they are or not, they have to recite the old earth view because they have to do that to maintain their jobs. And so there's a few out there that aren't. A few of them are young earth, like we are at ICR, but they still can't say much. And so there's most of the park. You go here at any sort of geologist at the park, they just give you the company line. Basically the conventional storyline of millions of years, and this park developed over millions of years. They don't think about what you're really seeing.
Yeah.
Why is that magma still hot? After all this time, why is that magma still hot? Why isn't it crystallized? And they just don't quite put two and two together sometimes.
Well, my recommendation for all of our viewers and listeners is that everyone should go to Yellowstone if you can. It's beautiful. It's an experience, experiencing the beauty of God's creation in a way that you can't really anywhere else because it's so unique. Before I get your concluding thoughts, I do want to mention we do have this book. I will hold it up to the camera. This Parks Across America book. It is chock full of parks across America. That makes sense. No, so it was authored by you and Dr. Thomas primarily.
Mm-hmm. And a few other authors helped on a few things, but it really covers 18, I think, of the parks, the first 18 parks we wrote about. And so we wrote about them in Acts and Facts articles, but we put in more pictures and a little more information in the book. Mm. So the book is really unique. And even has a map that you can buy with it.
Yes.
And that map is this huge National Geographic style map that you used to get when I was a kid. We get these big maps, and it's made out of paper that doesn't rip very easily. And it shows the parks in that book that are highlighted. And so we did our own version of the geology, showing the young Earth interpretation that these rocks are only thousands of years old, not millions and millions. And so there's a lot of good information on both sides of that map.
Awesome.
So if you get a chance to get the book, I would recommend getting the map along with it. There's a combination price for the two of them, which isn't a whole lot more. And so, but it really is a really nice book, really, really well illustrated. If you can't go, that's a good start. But it may inspire you to go.
Yeah.
And if you go, wouldn't hurt to take that book along with you.
Yeah. And we'll link to this. We'll do an iCard right here, and we'll link to this in the description, the map and the pack with both of them. It really is a fantastic resource. It's a great coffee table book because of all of the pictures in it. It's, beautiful, beautiful pictures taken by you and Brian and our videographer Clint and a lot of other folks. Joel
Kaut and others.
Joel Kaut.
A lot of our staff have taken a lot of the pictures in those.
Yeah.
It really is a good book. I highly recommend it, and it's at a modest price.
Yeah, absolutely. Well, before we close, do you have any final thoughts, any sort of conclusion that you want to impart, any sort of wisdom you want to impart to our viewers and listeners?
Well, after, like I mentioned earlier, I've been to Yellowstone probably about 20 times, different parts of it. And every time you go, it's still special. It still makes me, it's almost like, I become a kid inside again. It's just amazing. That park is just right there. The animal life is there. The plant life there is there. And of course, my favorite, the geology. But it all comes together in the beauty that God made for us. After the flood, he left this behind as a reminder of the flood in a lot of ways, because that magma is right there and the volcanic rocks are all around, showing us what happened during the flood year. And again, part of the judgment the flood was that judgment is on display in all of our national parks, especially at Yellowstone National Park. If you go to Yellowstone, you got to go to the Grand Tetons, which is just to the south as well, which will be in an upcoming episode.
Yes, absolutely. It's kind of wild. This thought just came to me. They're so beautiful, and we go and we admire the beauty, but it is a monument to catastrophic destruction. And God warned Noah, and Noah preached for years to tell people there's going to be a flood, there's going to be this worldwide catastrophe, and only 8 people got on the ark, Noah and his immediate family. And so today, Jesus, through his word and through his disciples, written all these letters in the New Testament, telling us that, Jesus provides the way for our salvation today. He took our place on the cross. He died for us. He loved us before we loved him. He loved us that much that he was willing to die for us. And he did, but he rose again. And he opened up that door of salvation. Just like the ark was salvation for the people at the time of the judgment of the flood 500 years ago, now Jesus is the door of salvation. Amen. Yeah, that's great. There's no better way to close than giving the gospel. So thank you so much for being here. I look forward to speaking with you on our next episode, where we will discuss more parks.
All right.
And then our next episode, where we'll discuss more parks.
Okay.
I think currently we have 4 episodes discussing parks coming up. So
it's like a series that never ends.
Yeah. No, well, we can continue to do more. We'll take a break after 4. But
all right. Well, thank you very much for having me here today.
Absolutely. And thank you to all of our listeners and viewers for joining us for this episode of the Creation Podcast. If this has been helpful, encouraging, if this has provided you with any sort of desire or inspiration to go to Yellowstone, give us a like, subscribe, share this video with your friends and family. If you want to get the Creation Podcast 1 week early, or our other podcast, Creation.live, 2 weeks early, you can become a member here on YouTube or on Patreon. And there are links in the description that will allow you to do that. But for now, I'm Trey, and we'll see you next time on the Creation Podcast. We want to say a huge thank you to our members and patrons. If you'd like to see your name here and unlock perks like early access to our podcasts, members-only polls and live streams, behind-the-scenes footage, or exclusive video content, links are in the description below.